Hi again. All right, so this is the first lecture of all the different non-renewable energy sources that we're going to cover. So we just went over an overview of sources of energy, both globally and within the United States, and we showed that globally, most of our energy, and within the United States, most of our energy comes from petroleum or oil. But as far as electricity, that energy comes mostly from coal. We mentioned there's a variety of forms of non-renewable energy sources out there, and the first of which I'm going to talk about is coal. So let's start there. If you think back to all the various cycles, remember the biogeochemical cycles? So coal, carbon, nitrogen, phosphorus. Within the carbon cycle, we said that carbon, either on land or in water, could eventually form fossil fuels if they were deposited in these anaerobic environments, so environments without oxygen. Because if there's oxygen, then all these organisms are going to eat up all of the critters and decompose them, releasing all that energy locked up in those carbon bonds. So, if carbon, in the form of organisms, is deposited in an anaerobic environment, all that energy remains locked up in those carbon bonds. We also mentioned that there are two primary places on our planet where there's very low oxygen content. One of those is the bottom of the ocean, and the other was in swamps. And coal is really the remnants of these ancient swamps that existed millions of years ago in the world. And it was in these swamps where all this vegetation died, fell into the water, which had low oxygen content, and were covered in various layers of sediments, eventually, hopefully, a little bit of luck, to become coal, oil, natural gas, or something like that. This diagram, which comes from your book, shows the progression in the formation of coal. So here we have one of our ancient forests. It actually didn't look like this at all. It's kind of funny. They show it. These are all modern day plants. The plants that existed in these forests look nothing like this, but we'll let them slide on that. So when plants die in this low oxygen environment, the first thing they form is peat. And peat is not coal. It is simply partially decayed organic matter, plants. And we even looked, I think, at the guy, the bog man, right, that they found in the peat bogs of Europe and England. This guy was wasn't decomposed at all, was intact. You could see his skin, his hair, and all that kind of stuff because of this low oxygen environment and because of the acidity as well and the tannins and stuff. So if you take peat and you allow it to be buried in sediments, and here we have this sediment layer here, and you compress that peat, extracting some of the water, you can form the first kind of stage of coal. So this stage right here that we're showing, this progression, this is the various stages of coal. Again, peat is not coal. So lignite is kind of the first stage of coal. Still has fairly high water content in it. It hasn't been compressed that much. With further compression, you can form what's called bituminous coal, or first subbituminous and then bituminous. So that's further compressed plant matter, and it has less water, and it burns hotter than lignite. With more time, that bituminous coal can become what's called anthracite. Anthracite is highly compressed plant material, very low water quantity, and burns very hot. So it's very desirable. Anthracite, good stuff. Burn it today. So these are the stages of coal as you progress from these ancient forests that fell in anaerobic conditions and were buried in sediments, were compressed further and further, extracting more and more water and making them more and more dense. So here you can see an image of lignite this kind of gray, and we'll look at some of these in lab, versus anthracite, which is this very shiny, very dense material. Now, coal is fairly abundant in the world. There are a lot of reserves. We have hundreds of years worth of coal, especially in the United States. Within the United States, you can see from this map that we have large deposits of bituminous coal in the Midwest. We have large deposits of subbituminous and lignite in the West, the Rockies. And we have small deposits of anthracite in Pennsylvania and in West Virginia. So remember, those are the most desirable deposits. You get the most bang for your buck. You get the most heat out of it. But we have very little left in the United States. If we look globally down here, you can see that North America, this includes Canada as well, but a lot of this in the United States, we have some of the largest deposits of coal in the world. We're coal kings. This former Soviet Union, it's primarily Russia, has also very large deposits of coal. China, Asia and Oceania, Australia being a large proportion of that, also have fairly large deposits of coal. China is exploiting that coal and creating much of their power using coal. If you compare this to South America and the Middle East, they have very small deposits of coal. So coal is cheap, relatively accessible, and we have a lot of it. So therefore, we really want to use it to generate our power. The only problem is that it's pretty dirty. Matter of fact, it's probably considered the most polluting, the dirtiest form of these non-renewable energy sources. We already talked a little bit about the mining process, actually quite a bit about the mining process, either using surface mining with strip mining, mountaintop removal, or subsurface mining processes. This is damaging to the ecosystems, habitat loss, as well as environmental effects from the tailings, acid mine drainage, and leaching of selenium and other arsenic and other heavy metals from the tailings. When you burn coal, you also get quite a few different emissions. So when you burn it, you release a lot of CO2. Matter of fact, of all the fossil fuels, coal releases the most CO2 into the air. Mercury emissions is a unique pollutant associated with coal. I can't remember if we've actually talked about the problems with mercury, but mercury bioaccumulates, so it accumulates within the fatty tissue of organisms, and it can biomagnify. So as you move up in trophic levels and up a food chain, it becomes more and more concentrated, so you get higher and higher concentrations. Mercury is a neurotoxin, and it causes birth defects, and we'll talk more about this in later chapters when we talk about environmental health. It's nasty stuff. We don't want it in our bodies. But most of the mercury is in the environment comes from coal. So coal is the major source of mercury. When you burn coal, you also release sulfur into the environment, and this is in the form of sulfur dioxides. And we already know that sulfur dioxides can lead to acid rain and can also contribute to smog. So depending on where the forests were found back in these ancient forests millions of years ago, depending on what environment they're growing in, they will have varying amounts of sulfur in the coal itself. So depending on where the coal is mined, that coal may or may not have high amounts of sulfur in it. There are actually types of coal that have fairly low amounts of sulfur. Matter of fact, most of the anthracite that comes from Pennsylvania and West Virginia is fairly low in sulfur. But other deposits can be relatively high, which leads to acid rain and these other problems. You also have the problem of ash with coal, or with coal burning, it's called fly ash. When you burn the coal to create the heat and generate electricity, eventually you accumulate quite a bit of ash. Now, coal burning plants, along with most electricity generating plants, need to be near water, right? You need the water to cool the process and to generate the steam. So most coal burning plants are next to rivers. After you've burned coal for a while, you have all this ash, you need to do something with it. There are actually a lot of different ways of recycling that ash, either putting it into asphalt roads, putting it into wallboard that you'd use inside of a building or a house, but most of it actually just accumulates next to the coal burning plant. And they usually create little dikes or little like levees around it so that that ash sits in there, and any rainfall that is accumulates in that area is retained within that area. A couple years back, I think it was 2010, there was a large accident on the Tennessee River where a coal burning plant had its retainer walls broken apart through heavy rains, and all that ash flowed into the Tennessee River. It created a huge mud, slurry sludge that just worked its way down the river, enveloping neighboring homes and that kind of thing. So here's a picture. This is actually from your book, showing one of these homes being consumed by the ash muck. Now, there's an interesting environmental justice problem associated with this as well, because after the Tennessee Authority agreed to clean it up, and they essentially went in and dug all this stuff up, they had to do something with it. Well, this ash from these coal burning plants contain a fair amount of mercury. They contain arsenic, other heavy metals. So it's toxic stuff, and that's why they had to clean it up. So what do you do with trainloads of sludge that has toxic material into it? Well, you'd send it to Alabama, which is what they did. So they found a county in Alabama that was, I think, 70% of the population was below the poverty level, something like that. That's actually not right. Not 77. It was an extremely poor county, primarily African American, and the council members said, "Yeah, we'll take your money and we'll put it in the dump here," which is probably not the best thing for the community members, but did allow the council members to have quite a bit of cash to do some of their pet projects. So, again, an interesting environmental justice question that arises from the generation of this electricity. So, coal, cheap, abundant, fairly easily to get, but it is dirty. A lot of problems associated with coal. But we have many hundreds of years worth of coal to burn if we want to. So there's your dilemma. Next, we'll move on to oil and see what that's all about. Bye.